All right, this is Ubaid on behalf of Electronics, and in this video we'll be looking at radicals. Okay, so when it comes to radicals, okay, we're looking at something like this. Okay, so this would be an example of a radical where you have a square root of 25. Okay, where the square root, okay, or the number 2, okay, this is your invisible number outside your square root. Okay, this will be your index. Okay, and the sign itself, the square root sign, will be your radical sign. Okay, and whatever number you have inside that radical sign will be your radicand. Okay, so let's take another example. Okay, so let's say this is square root of 9. Okay, so we know that there is an invisible number over here. This is number 2. Okay, this will be your index. Okay, this sign over here for the square root will be your radical sign, and whatever number you have inside the radical sign will be your radicand. Okay, and we know that square root of 9 will be 3. Why? Because 3 square, okay, which is basically 3 times 3 is 9. Okay, so let's take another example. Okay, let's say this is the cube root of 27. Okay, so we know the cube root of 27 is 3 as well. Okay, because 3 cubed is basically 3 times 3 times 3. Okay, which is 27. All right, which means you get 3 as your solution for this, okay, for this question over here. Okay, so further down, let's take another example. Okay, let's say this is cube root of 8. Okay, we know that cube root of 8 is 2. All right, because 2 cubed is basically 2 times 2 times 2. Okay, which gives you your solution, 8. Okay, and this is what we're looking for over here for this radical. All right, so when it comes to radicals, radicals do have many applications. Okay, and we're going to explore some of the applications for radicals. Okay, however, before we go ahead and explore some of the applications for radicals, let's talk about the product and the quotient rule for radicals. Okay, so when it comes to the product and quotient rule, we're basically talking about multiplication and division. Okay, and the reason why we need this rule, okay, is to make sure we can simplify and arrive at the correct solution. Okay, so let's say, for example, you have square root of 9 over square root of 4. Okay, so this is basically, okay, 3 over 2. All right, if you have, okay, square root of, okay, 25 into or multiplied by, okay, under the same radical sign, you have 9. Okay, so this is basically the same as saying this is square root of 25 into square root of 9. Okay, which means that this is 5 by 3. Okay, which is basically 15. All right, let's take another example. Okay, so let's say, okay, this is square root of 9 into square root of 4. Okay, so this will be the same as saying square root of 9, where 2 is your index. Okay, this is your radical sign, and the number 9 inside that radical sign is your radicand. Okay, this will be the same as square root of 9 times square root of 4. Okay, which is the same as saying this is 3 times 2. Okay, which means this will be 6. All right. Further down, let's take another example. Now, before we move on to the next example, okay, this is basically your product rule, okay, where any number that is multiplied by another number inside the radical sign is the same as saying this number is a separate radical multiplied by all the other numbers, all the other separate radicals inside this radical sign over here. Okay, so if you have two numbers inside a radical sign, this is the same as saying this is the square root of number 1 times the square root of number 2. Okay, so let's take another example. Let's say this one over here, this is square root of 25, okay, times the square root of 9 divided by the square root of 9 times the square root of 4. Okay, so this is the same as saying this is 25 into the square root of 9, okay, all divided by the square root of 9 into multiplied by the square root of 4. Okay, which is the same as square root of 5. Okay, 25 will be 5. Square root of 9 will be 3. Okay, so this will be 5 times 3 is 15. All right, 15 over. This will be 3 times 2. Okay, which is 6. Okay, so this will be your solution. All right, let's take another example. Okay, and this is basically your quotient rule. Okay, so when it comes to your quotient rule, okay, you're basically dividing two radicals. Okay, when you divide two radicals, okay, all the numbers under the first and second radical sign, okay, basically are their own radicals. Okay, which means that if this is a square root of three numbers, okay, this will be the square root of first number times the square root of second number times the square root of third number divided by. Okay, if this is, let's say, the cube root of two numbers, it will be the cube root of first number times the cube root of second number. Okay, so let's take another example. Okay, and that will be basically your quotient rule. Quotient has to do with division, product has to do with multiplication. Okay, so when it comes to the product rule, let's say you have the square root of, okay, 18. Okay, now notice, okay, this will be a decimal if you use your calculator. Okay, which means that 18, root of 18 is 4.24. However, when it comes to radical expressions, we will need to simplify this number. Okay, basically it means that this will be 9 square root of 9 times 2. Okay, which is basically the same as saying this is the square root of 9 times the square root of 2. Okay, which is also the same as saying this is 3, okay, times square root of 2. Okay, so this will be your solution. All right, so the same goes for your quotient rule. If you have division instead of multiplication, okay, you will need to make sure you simplify all the numbers inside the radical sign before you go ahead and find the radical. Okay, so that's basically your product and your quotient rule. Okay, now when it comes to real world applications, okay, let's go ahead and solve some of the applications over here. So let's say the current I measured in amperes is given by the formula I equals square root of P over R, where P is the power usage measured in watts, and R is the resistance measured in ohms. If a 100-watt light bulb has 160 ohms of resistance, find the current needed. Round to the nearest hundredth of an ampere. Okay, so I equals square root of P over R. All right, so this is I equals square root of P over R. Okay, so we know that I stands for current. Okay, current in an ampere. So when you look at your circuit, Okay, let's say your circuit looks something like this. Okay, 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 so something like that. And you have current passing through this circuit. Okay, so you have parallel circuit and you have a circuit in series. Okay, so nevertheless, you have current passing through both types of circuits. Okay, so that current is basically the movement of electrons. Okay, and it's passing through the circuit. Okay, and this is the current that we use to power up our consumer electronics, your cell phone, your laptop, okay, whichever electronic device you might have. Okay, so let's say the current is equal to P. Now, power, okay, power is in watts, okay, and that has to do with, okay, let's say, for example, in this case, a light bulb, okay, so power, this is P, and power is 100 watts. Okay, so let's say this is 100 divided by R stands for resistance. Okay, so notice this sign over here. Okay, this is basically your resistance. Okay, now resistance is basically something that resists the current. Okay, so if you put a light bulb, for example, on a circuit, it will resist the current because it will consume the current, okay, to some extent. Okay, in an electronic circuit, you have resistors, okay, specially designed to resist the current. Okay, so when it comes to resistance, let's say R, this is basically 160 ohms. Okay, and that's the measurement. So this is what ohms looks like. Okay, and this will be 100 watts. Okay, and current is in amperes. So I, which is basically in amperes, or A, this will be the square root of 100 watts divided by 160. So we know that this is the same as saying the square root of 100 watts, okay, divided by the square root of 160 ohms. Okay, this is using your quotient rule. So now we know that the square root of 100 is 10, okay, and the square root of 160, okay, we can either simplify it or we can use the calculator. So if you use the calculator, the square root is 12.65. So this is 12.65. Okay, so 10 divided by 12.65, this will be 0.79. Okay, which basically means this is 0.79 amperes, or A. Okay, so again, the question was, if a 100-watt light bulb has 160 ohms of resistance, find the current needed. Round it off to the nearest hundredth of an ampere. Okay, so we found the current, which is 0.79, and this is your solution. Okay, some of the other applications when it comes to radicals include, but not limited to, math, engineering, physics, chemistry, and biology. Okay, so for math, you can use it to calculate distances, simplify expressions, solve equations. For engineering, design parameters. Okay, physics, laws of motion and gravity. Okay, your Pythagorean theorem, chemistry. Okay, biology, and everyday life. All right, which covers finance. Okay, to calculate or figure out your interest. So this is basically how you use and solve radicals. On behalf of V Electronics, this is Obey. Have yourself a great day.